Okay, question 5 takes us to everyone's favorite section, functions, my bro. Alright, f of x has this equation. Okay, thanks for that. That's really helpful. And g of x has that equation. G is even more helpful. Okay, let's get these graphs highlighted. Yes, that's so much better, bro. Okay, x-intercepts of f are at points A and C. I like to put dots on those points. It just makes my brain see it a bit easier. And the two graphs intersect at points A and B. Intersect is a fancy way of saying where they touch each other. And P is the turning point, so that's quite important. And Q is a point on G such that the line PQ is parallel to the y-axis. So PQ is parallel to the y-axis. That's a fancy way of saying P and Q will have the same x value, which we'll deal with in later questions. Okay, now we can determine the equation of G. G is the green graph, and it's a straight line. So let's run through how we get the equation of a straight line. Okay, so a linear function has the standard form of y equals mx plus c, but they've named this one mx plus k just to confuse us a little bit. So this isn't a c, it's a k in our case. And that doesn't change much. It's still a placeholder for the y-intercept. So, with the green graph, if we know where it cuts the y-axis, hey, how's it, brother? It cuts the y-axis at 8. So the y-intercept is 8, so I can immediately change that to an 8. And now to get the gradient, I can go one of two ways. I can use the gradient formula between these 2 points, A and B, or I can just sub in a point straight here and get m. So I'm going to do the gradient formula because you use that formula a lot, and it's worth your time to practice it as much as you possibly can. And luckily the gradient formula is on your formula sheet. So we're going to put a point in over here, and we're going to put a different point in over here. I like to start with one at the top. It really doesn't matter which one you start with. So I'm going to put B in here, so 8 will go here and a 0 will go here. And now I've got to use a different point on my line, so I'm going to go down to A. So the y value there is 0 and the x value is minus 4, so I'll put a 0 here and a minus 4 there. Okay, and then if we just pop that in our calculator or work it out mentally, I would personally pop it in my calculator, as you know by now. We're going to get 2, and that makes a lot of sense because this is going uphill, so I'm expecting a positive gradient. So now that we know the gradient, we simply just put it into m's place. And then the equation of the line is y equals 2x plus 8. So I'm going to fill it in here, and we're going to go through where the marks come from quickly. First mark comes from the substitution into the gradient formula. The second mark comes from the correct gradient of 2. And the third mark comes from the correct c value. Next up, we need to calculate the values of a, b, and c in f of x's equation. So it's a fancy way of asking you get the equation of the parabola. And we can do one of two things to get that accomplished. So I can do it in one of two ways. I can use this formula if I have the x-intercepts, or I can use this formula if I have the turning point. Now if I look here, I don't have the turning point. I don't know the coordinates of P. But I have the x-intercepts, so we found our winner chicken dinner, but... Okay, now we're going to slap those x-intercepts inside over here. So, the first x-intercept is minus 4. And the second x-intercept is 2, so I'm going to clap a 2 in there. Okay, and then minus 4 will become plus 4. And you really want to get comfortable enough just to write this straight away. So what I remember is it's the opposite signs. So if this one is negative 4, this one will be x plus 4. If this one is positive 2, this one will be x minus 2. Okay, now to get a, we need to sub in a different point and then solve for a. So if I scope out my blue graph, hey, how's it, bro? We've got a point here, so we're going to sub it in to get a. And we're going to sub it in immediately. And when I sub it in, just remember the first one is x, the second one is y. So we're going to change this y to an 8. The a stays there because that's what we're solving for. Okay, then I'm going to sub 0 into x's place. So in these two empty little spaces, we slap a couple of kandas in there, my bro. So now, we are going to simplify the brackets. 0 plus 4 is 4, and 0 minus 2 is minus 2. And then 4 times negative 2 is negative 8. Negative 8 times a is negative 8a. And now I need to get a by itself, so I just divide both sides by minus 8. And these minus 8s cancel, and 8 divided by minus 8 will give you negative 1. So we officially have the a value. Okay, now what I'm going to do is I'm going to grab this very first line quickly. And then I'm going to change a to what we just worked it out to be. So I'm going to sub that a value into a's place. So I'm going to go ahead and change that to a negative 1. And now we've got a form of an equation for the parabola. Now they want it in this format, and to change this format into that format, I need to FOIL and distribute, my bro. And when I FOIL, I'm going to keep it wrapped in brackets because I'm going to have to distribute this negative 1 after we FOIL and simplify. X times x is x squared. And then I get a minus 2x with the outer terms, a plus 4x with the inner two terms, and a minus 8 with the last two terms. And now we're going to do the like terms in the middle here. So minus 2x plus 4x is just a plus 2x. And the last thing left to do is distribute that negative 1 into the bracket. So we're just going to yoink it in there quickly and see what it gives us. And we have arrived with the equation. So we've got minus x squared minus 2x plus 8. You can see how this positive changed to a negative, this positive changed to a negative, and this negative changed to a positive. So you get a sign change happening when you distribute a negative 1 in. That's a small little shortcut you can learn. And then to fully answer their question, calculate the values of a, b, and c, we read it off of this graph. So the number in front of x squared is a. And just remember, if there's no number here, it's a sneaky weasel, my bro. It's a 1. The number in front of x is b, so b is negative 2. And the number that does not have an x is your c value, so c will be 8. Yes. Alright, let's see where the 16 billion marks come from. Okay, your first mark comes from the substitution into the x-intercept formula. The second mark comes from the correct value of a. Third mark comes from your standard form over here, and the last 2 marks come from the correct value of b and c. In 5.3, we need to show that the coordinates of p are minus 1 and 9. Okay, check what p is, bro. It's the turning point. So we're going to use the turning point formula. Okay, and this formula, you really want to know it off by heart. It is not on the formula sheet. So memorize it because they always ask it. And then a and b can be found in the equation of the parabola. If there's no number here, it's a sneaky weasel. It's a 1. So a is minus 1 and b is minus 2. We're going to chuck them in here and see what it gives us. Okay, and then I kind of already know what it's going to give me. It's going to give me negative 1. If you slap that in your calculator will agree with me, bro. And then that's the x value of p sorted out. And to get the y value, anytime I want to get a partner, I'll sub this into the graph. So p is on the blue graph, so I'll sub it in here to get his partner. So let's grab that equation. And then anytime I see an x, I'm going to put open brackets like this. And inside of those open brackets, I'm going to clap that minus 1 into them, boss. And then that is a calculator problem. But I know what it's going to give me. It's going to give me 9, bro. Can the honorable calculator agrees with me? So it gives me 9. Yes. Okay, and then I just have to write, therefore p has the following coordinates of negative 1 and 9. Be sure to put that straight on your sketch. And let's have a look where the 2 marks come from. First mark comes from the substitution into the turning point formula. A second mark comes from the substitution of this value, x value, into the parabola to get the y value of 9. Next up, we need to get the range of f. F is our parabola, the blue graph, and when you're doing range, you only look at y values. Okay, and then to get the range, we start from the bottom and go up. So if we start from the bottom, this graph goes on forever downwards, so we say it starts at negative infinity. And then I keep following it up till where it ends. So if I just keep going up, and keep going up, we can see that the turning point is the last point that this parabola ever reaches. So the last ever y value it's ever going to reach is 9. So we kind of say it starts here and it ends there. And how we write that mathematically is we say x is an element that starts at negative infinity. Infinities always get circle brackets. And it ends at 9, and then we clap a square bracket there because it does include 9. The graph does exist at 9. And there is another way to write it if you don't like that way. You can simply just say the y values are always going to be smaller than or equal to 9. That's a shorter way of saying what we said previously. My personal preference is the previous one. It helps you see where it starts and ends better, and then this comes naturally after a while of getting used to the first one. So yeah, you just get 1 mark a pop there. In 5.5, we need to determine the equation of a new line P that is perpendicular to G and it passes through the point C. So let's draw that so we can understand what we're actually doing. So we know 2 things about this line. It is perpendicular to G, which is the green graph. So the orange graph I've represented as P. So it's perpendicular, aka at a 90-degree angle. And it also passes through point C. So it's going to go through point C over there. And now to get the equation of a straight line, I'm going to use my classic y equals mx plus c, bruh. Okay, and if I'm going to use y equals mx plus c, I need the gradient. So to get the gradient of the orange line, we have to use the perpendicular lines formula gradient. Oh my word, I butchered that one. We're going to have to use the formula for perpendicular lines. And just to run through that formula quickly, when you multiply the gradients, you get -1. And a shortcut is you can flip the fraction and change the sign. So you see how this was 2 over 5. I flip it to get 5 over 2. And then this one is positive, so this one will be negative. So let's grab this formula and start playing around with it. Okay, so my first gradient will be the gradient of this green line, which is the number in front of x, which is a 2. So I'm going to slap a 2 in here, but... And then I need to get this gradient on its own, so I just divide both sides by -2. Divide by +2, sorry. Okay, these 2's cancel, and I'm left with the gradient to be -1/2. Okay, after we get our gradient, we're going to do y equals mx plus c, like we discussed earlier. So I'm going to slap that gradient in there, but just like that. And now we need to get the c value, and to get the c value, I sub in a point. So I've only got 1 point on my orange graph, it's C. So I'm going to sub C into that formula and solve for C. Okay, so we're going to sub in this point, 2 and 0. Remember the 2 goes into x's place and the 0 will go into y's place. -1/2 times 2 is -1. Okay, and then we're almost there. So this -1, I'm going to yoink it over to the other side and it becomes +1. And we officially have c to be 1, and c is representative of the y-intercept. So now I know this point here is 1, and it does look right according to the sketch. So there's one last thing left to do. I'm going to put c back in there and rewrite it. And now we officially have the equation of the line P, and if it makes you comfortable, you can change this y to a p of x like this. And then that's officially klar, my bro. Okay, so let's have a look where the 3 marks come from. Your first mark will come from the gradient of the orange line. Second mark comes from the substitution of this point C to get the C value of 1. And the last mark comes from the correct final answer. Next up, we need to determine the length of line PQ. PQ is over here. And earlier on in this question, they told us something about PQ. They said PQ is parallel to the y-axis. And that's a very fancy way of saying that PQ is a perfectly vertical line, which implies that the x value for P will be exactly the same as the x value for Q. Now, to get the length of a perfectly vertical line, I use the following formula. I'll take the y value on top and I'll minus the y value at the bottom. So here's the y value on top and the y value at the bottom. We don't have that, so we're going to need to get it. And if I want to get a partner, I'll take this x value and sub it into the green graph there. So let's go ahead and do that quickly. And then we just pump this in the calculator or work it out mentally. It will give me 6 when I work it out. And now we officially know that y value for Q. So our vertical line is named PQ. So I'm going to change this to a PQ. And the y value on top is 9. So I'm going to change that to a 9. The y value at the bottom is 6. And 9 minus 6 will give me 3 units for the length of PQ. Okay, let's have a look where the 2 marks will come from. Okay, the first mark comes from g of -1, aka getting that y value, and the second mark comes from the correct final answer of 3 units, my bro. And then welcome to your challenge round, for which values of x is f of x divided by g of x bigger than or equal to 0. Okay, f of x and g of x are fancy ways of saying y values, my bro. Okay, and the best way to approach one's axes is you start all the way on the left of your graph and you draw a vertical line. And if I draw a vertical line here, I'm going to start analyzing the x values. The y values. So if I look at the y value here, it's got a negative y value because it's under the x-axis. And if I look at the blue graph over here, that's also got a negative y value. So I'm going to get a negative y value divided by a negative y value, and a negative divided by a negative is a positive. And when I say something is bigger than 0, that's a fancy way of saying it's positive. So it's working over there. And I'm going to draw another vertical line over here and analyze it there to see where it kind of starts and ends. But before I do that, I'm going to have a look at this point over here. Now this point over here, both the y values of the graph is 0. And I'm going to get 0 over 0, which is undefined. I cannot divide by 0. So this point here does not work. So it's going to work from minus infinity all the way up to -4 for my first interval. And I do not include -4, so I'll put round brackets because it's going to be undefined there. Okay, now we're going to move along the graph. Now I'm going to draw the vertical line here and analyze. Okay, and if I draw my vertical line over there, the blue graph has a positive y value, and the green graph also has a positive y value. So I'm going to get a positive divided by a positive, which will give me a positive number. So it's working over there, and it keeps working until I reach this point. So I'm going to set up another interval that starts here and ends over there. And then I can include 2, because the blue graph will have a y value of 0, and the green graph will have quite a high y value there. So I'm going to get 0 divided by quite a big positive number, which will give me 0, and it can be equal to 0. So I'll slap that square bracket on there. And now, just to illustrate to you why it won't work after 2, I'm going to draw the vertical line up here. And if I draw the vertical line over here, we can see that the green graph will give me a positive y value, and the blue graph will give me a negative y value. So in that case, I'm going to get a negative divided by a positive, which won't satisfy this inequality. So we are done after writing these 2 answers. Yes, this question was just straight up nasty, my bro. Okay, you're just going to get 2 marks for both of your answers there. Bear in mind there is a faster way of writing this, but I would personally recommend this version of it. So those previous 2 we can combine into 1 and say x must be smaller than 2 with the condition that x cannot equal -4. Because we established that it works everywhere before 2 except this point. So that's why this notation also is acceptable. And that wraps up question 5, my China beans.